Okay, now continuing on with domain 4.1, we're going to go over different wireless security settings. Going to dive a little bit deeper in how we can protect our Wi-Fi, guys, in our organization. So wireless security settings are crucial for protecting wireless networks and the data transmitted over them. So when we're doing wireless encryption, the standard now is WPA3. WPA2 is not necessarily vulnerable, but this allows us extra protections against brute force, provides us perfect forward secrecy when doing WPA3 PSK, okay? So that's the latest security protocol for Wi-Fi and improves encryption and protection against brute force. If we're doing WPA3 Enterprise, where we're going to want users to log in via username and password or maybe some credential, we're going to want to use AAA and Radius for a framework to actually authenticate users using username and password. And then, of course, cryptographic protocols. We always want to ensure we're using strong cryptographic protocols when doing data transmission over our Wi-Fi or wireless networks. So we're going to have different authentication protocols. So EAP is our authentication framework. And the most secure framework we're going to want to use for authentication, right? We're not talking encryption. Authentication is going to be EAP TLS or TTLS. What this does is actually enforce certificates to be used with devices connecting to our Wi-Fi. Of course, network segmentation. When we have our different wireless local area networks, those different broadcasting SSIDs, whether they're from a single access point, we have 10 SSIDs broadcasting, are going to be part of different VLANs. So we do network segmentation as well for our wireless traffic. So if you ever see, like, let's say you work at example.com, if you see example 10, example 20, or maybe you have example ACCT for accounting as SSIDs all throughout your environment, that means if you're a user in the accounting department, you connect to that SSID using your username and password. So we have multiple wireless LANs configured from a single access point or for all of our access points for our roaming users. Application security. So application security involves measures and processes to protect applications from threats throughout their entire life cycle. So just going over some high-level things we should do to protect and secure and lock down our applications built for our organizations. That's going to be input validation. Ensure that all input received by the application is validated. It's going to prevent common vulnerabilities such as SQL injection, cross-site scripting. Having secure cookies. So if we're doing like full-stack web development, implement secure cookie handling practices, including setting the secure and HTTP-only flags to protect against cross-site scripting and session hijacking, where an attacker could potentially steal that secure cookie and then use it to re-authenticate. We also want to perform code analysis. So we have static code analysis. This is where we take the source code and we're going to analyze it. And there are some plugins we can use in like our integrate development environments, like in VS Code, that's going to allow us to look and see if there's any well-known vulnerabilities in our source code. There's also things like Copilot now or GitHub Copilot that can do a lot of this stuff via AI. So more application security. So we can digitally sign and do code signing on our source code, right? We can actually put a digital certificate on there that allows us to verify the authenticity, integrity, and ensure non-repudiation. So we also want to do patch management of our custom-made applications, making sure we update and making sure if a known vulnerability comes out from maybe a third-party library or software development kit that we integrated, that we're patching. Sandboxing. So sandboxing is a security technique where a separate isolated environment is used to run and test untrusted programs or code. So with sandboxing, that's going to give us an isolated environment to do a lot of different things, guys. We can do malware detonation there. We can run our code to make before we put it into production. A sandbox environment allows us to do testing and analysis, deploy our code, and then we can do like fuzzing, right? Where we actually try to do SQL injection, cross-site scripting attacks. And we have controlled resource access. So a sandboxes limit the resources and access rights of the code running within them. So that's good though, right? We want that to minimize the potential impact of malicious actions when we're doing malware detonation or trying to break our code. And then monitoring. Of course, we always want to implement monitoring at every single level, from our systems to our network to the data flow, and even on our applications. We want to have real-time detection, implementing things like IDS, enabling AI and ML behavior or features on our IDS and our SIM systems or our SIM systems to create behavior baselines and patterns. Log management. Again, I'm going to keep saying it. Our SIM systems that we deploy, we can use that to aggregate all of our logs and do log management and log diving so we can do passive monitoring. And then alerting and reporting. We want to set up the proper alerting mechanisms to notify the relevant personnel, the SOC team, the necessary stakeholders, and we want to fine tune that alerting. So we probably want to use some sort of scaling to say, okay, we alert if it's a level 10, we don't alert if it's a level 1, or we alert in the morning, something like that, right? You just want to be cognizant of how we're alerting and how fine-tuned that alerting is. Okay, let's go ahead and do our domain quiz now. Okay, so question 1. Why is input validation crucial in application security? That's going to be C, to prevent attackers from injecting malicious data, potentially leading to security vulnerabilities such as SQL injection. Question 2. What is the main purpose of code signing in software security? That's going to be B, to ensure that the software originates from a known source and has not been altered after it was signed. Question 3. What is the primary security enhancement introduced with Wi-Fi protected access 3? That's going to be B. So I didn't describe in the slides how it does extra brute force protection and provides perfect forward security, secrecy, excuse me. That's because it does SAE, simultaneous authentication of equals, where it's going to replace that pre-shared key and enhance protection against offline dictionary attacks for every single authentication session, okay? So it introduces a technology called SAE. Question 4. How does sandboxing contribute to application security? So that's going to be B, by running applications in a restricted environment to contain malicious actions. Question 5. What is the primary role of AAA, authentication, authorization, and accounting services within Radius in network security? That's going to be C, to centralize authentication, enforce access policies, and log user activities for network resources. Then the last question, what is the primary benefit of using packet captures in network security investigations? That's going to be B, to capture and analyze network traffic, providing detailed insights into data packets for incident analysis and troubleshooting.